All right, we're going to take a look back at moles and make sure we know what's going on moving forward because we're going to be using moles an awful lot in the next unit. So technically the definition of a mole is the number of atoms in exactly 12 grams of carbon-12. We notice if we look at the periodic table, carbon's atomic mass, remember these are average masses, weighted averages based on the isotopes and their abundances, but this mass, we would say one carbon atom has a mass of 12 AMU. When we talk about a mole, because these masses are all relative masses reported in the table, a mole of any substance, which would be Avogadro's number, which is 6.02 times 10 to the 23rd atoms, if we were to measure out this mass from the table in grams, we would have a mole of any particular element. So if I measure out 12 grams of carbon, I would have 6.02 times 10 to the 23rd carbon atoms. If I measured out 32 grams of sulfur, I would have 6.02 times 10 to the 23rd atoms of sulfur, and again, that would be 1 mole, and so forth and so on. If I have a compound, remember that we just look at the formula and add up, so if I have H2O, for example, that means that there's 2 H's and 1 O. So I would add up the mass of 2 H's, add up the mass of 1 O, and again, that expressed in grams, that's the mass of 1 mole. So we're going to work through a couple of sample problems here. Let's try a formula. Let's see here. Let's do, how about we do potassium sulfate, SO4. Sorry, it should be K2SO4. Now, obviously, I can't subscript in this spreadsheet, but there's those would be subscripts. So there's 2 Ks, 1 S, and 4 Os. So again, if I were to add up from the periodic table, I'm going to take the mass of potassium, 39.098. So again, if you want to round these off, you can at least take them to the first decimal place, or you should at least retain the same number of digits that the, if you're working a problem, retain the same number of digits that are given in the problem. So we'll just do 39.1 for each potassium. For sulfur, that's over here, that'll be 32.1. And then for oxygen, this will round to 16.0. So if we come back here, this molar mass is going to be, let's see here, potassium was 9.1 times 2 plus sulfur 32.1. Actually, let me just take out the spaces, plus, and then oxygen 16 times 4, 16.0 times 4, and that all adds up to 174.3. So this is the mass in grams of 1 mole. So this is 174.3 grams. That is equal to 1 mole, and oh, it doesn't like that format. And that is also equal to 6.02 times 10 to the 23rd. Now I have to, times 10 to the 23rd. Again, it's not going to let me exponent in this program, but 6.02 times 10 to the 23rd, that's the number of atoms in, or sorry, we're not talking about atoms. This is a ionic compound, so this would be formula units, right? So it's Avogadro's number of whatever it is we're counting. So you want to make sure you're careful with vocabulary. Okay, so this is the information we need to get us started. So let's say that I would like to know how many moles are in 22.8 grams of K2SO4 contains how many moles. Okay, so that's what we're going to set up first. So, oops, I should put this. So my initial number that I'm given in the problem, 22.8 grams, I'm essentially trying to use this relationship that we just came up with to convert between this and the units that I'm looking for. So I'm going to put that here, 22.8 grams. So we're always going to do a setup where we take the original number given and put that out front here to start with. and we're going to be multiplying it by a conversion factor. So the conversion factor, again, is taking numbers from this relationship, and we essentially want to get the gram to go away and get whatever unit we're asked for. So in this case, we're asked for moles. So I kind of don't need to touch Avogadro's number at all for this problem. It's nice to know how many formula units there are, but in a lot of problems that we're going to be dealing with in Unit 8, what we need to understand is that we use the mole unit because the numbers are going to be more convenient. Instead of having this gigantic 6.02 times 10 to the blah 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 if it's 1 mole, or if I had some other number of moles, it's way easier to deal with the mole unit and the mole numbers rather than these big gigantic numbers. So most of the problems we will be dealing with will involve going from grams to moles, moles to grams. But again, we still should be able to figure out how many formula units or molecules or atoms that means. Okay, so from the relationship, if I want mole, I'm going to put the unit I want on the top from this relationship. So again, this, even if you don't write it out, should be what pops into your head when you're asked to do a mole problem. And then the number on the bottom should have the matching unit to this one. So the mass from the table, and again, since this was a compound, we added up all the masses, that has the unit of gram. Remember that the number, the mole unit always has the number 1 next to it. Again, this is the definition of the mole, so it's always for 1 mole. Should have put my gram on there. All right, and so then we're multiplying by the top of our conversion factor, dividing by the bottom. This is not going to give me the ability to cross out my unit so you can see it, but what we're going to end up with is, again, it's 22.8 essentially divided by 174.3, and that gives us, again, calculator, or this program gives me a whole bunch more digits than I need. This original number, we're keeping the significant figures from that. So this has 3 digits, so I'm going to chop this down, to 3 digits. And again, the leading 0 does not count towards my total. So notice how it rounded off. So this is 0.130, and then I look to the number directly to the right of the one I'm keeping, and so it's going to round up to 0.131, and the units on this will be moles. Again, the abbreviation for mole is just MOL. Okay. What if I wanted to find the number of formula units? So find the number of formula units. And again, a formula unit is the same thing as a molecule, kind of, except we have to use a special term to refer to ionic compounds, which is what K2SO4 is, metal with nonmetal. You recognize that. Okay, so find the number of formula units. So same number. So you have an option here. You can take, since we already did this first part of the problem, I can take this 0.131 moles, or you could, start from scratch with 22.8. But since I already found out the number of moles, the conversion factor is going to be, well, now I'm taking it from moles to formula units. So it's 6.02 times 10 to the 23rd on the top. That has the units of formula units. The bottom is going to be the unit I want to cancel out. So again, 1 mole is equal to this number. So I'm plugging in from this relationship into my conversion factor. So that's 1 mole, and then that is going to equal, so 0.131 times, so again, multiplying by the top, 0.02 E23, and so that gives me 7.886. Again, keeping the 3 significant figures. So 7.8. We're gonna chop this down. Oops, wrong way. There you go. 7.89, and the units would be formula units. And you might also be given. Well, again, if I had this problem to start with, to find the number of formula units in 22.8 grams, if I wanted to go straight from grams to formula units, you could also do this. So notice I will end up with the same answer if I do it this way. So 22.8 grams, and using this relationship, so if this equals this, the grams also equals this number of formula units, so you could combine it all into one step if you wanted. And so this would be, again, the unit I want is the I want the formula units, so that goes on the top. On the bottom goes the molar mass, 0.3 grams. I should put my units on here so we can see it. Oops. And so then this equals, again, it'll be the 22.8 times the top of the fraction, and then we're dividing by the bottom. So times 6.02 times 10 to the 23rd, because that's on the top, and dividing by the bottom, which is 174.3. And there you go. And again, 3 digits should round down to 3 digits. And notice there's a little bit of a difference because I took this number was pre-rounded. Normally, if you were doing this, you know, if this was my end game, I would want to not round in an interim step and just carry this through. But again, we would label that with formula units. Now, other questions we might be asked is about, you know, if I look at this formula and I say, okay, within each formula unit, one formula unit of K2SO4 has, let's see what it has here. So it's got 2 Ks. So there's 2 K ions. Again, I wouldn't, you might hear them referred to as atoms, but technically they're ions because it's part of an ionic compound. Also, if I look at the formula, there is 1 sulfate ion per formula unit. There's also, again, if I want to pick this apart, there's 1 sulfur, there's 4 oxygens, equals 4 oxygen atoms. So here we call them atoms because those are a part of the sulfate ion. So if I'm asked to take this one step further, and if I, you know, and you'll see this in your practice problems, let's say that I have the, you know, this 22.8 grams, I want to know how many oxygen atoms are in 22.8 grams K2SO4. Oops. Well, again, I would have done these steps already, and then I would take this last step and say, okay, well, these are formula units of K2SO4, so I'm going to put this right here, and so I'm going to multiply this by, actually we'll put on the unit, oops, doesn't like that, 7.87 e to the 22. Just write it out then. So I have 7.87 times 10 to the 22nd formula units. And so again, I want to look at, okay, for each formula unit, well, how many oxygen atoms are there? So just looking at the formula without having written this out, right, where you get this from is looking at the formula. So there's 4 O atoms. So I'll be multiplying. So there's 4 O atoms per every 1 formula unit of K2SO4. So this isn't going to come up a ton, but this still is a problem that I think a bunch of us get hung up on, and so that's why I wanted to go over how to do it again. So again, we're going to have this original number of formula units we found times the number 4, and again, still responsible for holding that to 3 significant figures, and so that is the number of oxygen atoms. So it's 4 times the number of formula units we have. If I want to do any of these calculations in reverse, you know, again, if I'm given number of formula units and asked to find the mass, well, so let's say I'm given 5.67 e to the 20 formula units. So let's say that's the number of formula units of K2SO4 that I'm given, and I want to know what mass of K2SO4 would I have to measure out to get that number of formula units. Well, again, same setup. So if I'm starting with formula units, this was the given number, then I want to put, well, what am I looking for? In this case, if I'm asked for the mass of potassium sulfate, then I would put the number with the mass units from the relationship on the top, and then on the bottom, again, I want the FU formula units to cancel out. So that would be the 6.02 times 10 to the 23rd on the bottom, and then we are multiplying by the top, so my original number times the number on the top of the fraction, which is 174.3, and then dividing by the number on the bottom, and there you go. So again, this number has 1, 2, 3 numbers in the base number. Even if it's in scientific notation, we still follow the same rules, so I'm going to round this down to 3 significant figures. This would be that many grams. And again, if you look at this, 5.67 times 10 to the 20th, let's look at, does this answer make sense? Well, if I had 6.02 times 10 to the 23rd, so that's a much bigger number than this number, right? So a factor of 1,000 difference. So this number, I would get 174.3 grams. I've got about 1,000 times fewer formula units, and so certainly my mass comes out about 1,000 times lower. Right? So I'd have to measure out 0.164 grams to get this number of formula units. And again, if I look back at these numbers and if they make sense or what they mean, again, 174.3 grams, that's 1 mole, that's this number of formula units. Well, if I'm starting with 22.8 grams, that's a lot less than this number, which would be for 1 mole, so that's why it ends up being just a fraction of a mole, and similarly, just a fraction of this number, the number of formula units. So you should be able to check your answer. You understand this relationship, so this is the key thing to have down. Whether or not you write it out, it's your job to pick from the relationships between these 3 units. And again, for the most part, in this unit, we will be needing to convert from gram to mole, mole to gram, and not really touching formula units or molecules or atoms. So being able to do this conversion between grams and moles, extremely important. And again, if I had moles and needed to convert to grams, well, this fraction would be switched upside down so that we'd get the moles to cancel out and we'd end up with grams. But biggest mistake people make is putting the G with the wrong number. So again, this mass that comes from the periodic table, that has a G next to it. That's the grams, and then it's always equal to 1 mole. Always, every time, does not change. So you need to train yourself to think that. And just remember again, moles are number 1, so because they're awesome and they help us out. So there's 1 mole, and it's equivalent to whatever the mass is from the periodic table, and this thing is called the molar mass. There you go. There's your review of moles. So good luck on your practice and future calculations.